Notes for assignment 23 are Introduction to Lines and Slope. So if you remember in the last homework set, in the last notes for 22, we were doing something very much like this, where we had an equation and we completed a table and we plotted the points. Okay, so let's get some. We're going to be doing very much the same stuff today. Let's look at some definitions. A linear equation is an equation of the form ax plus by equals c. A, b, and c are integers. A is greater than or equal to 0. This is called the standard form for an equation, for a linear equation. Notice that the exponent on each variable is 1, so we're not dealing with x squares or y squareds. And in order to graph a line, you need to have at least 2 points. I think it's good practice to have more than 2 points, like 3, just to make sure that everything's lining up. But here we go. Problem number 1 is very similar to what we just did in our work for notes 22. Use the linear equation, 3x minus 2y equal to 12, and complete the table for the ordered pairs. I think it would be a good opportunity for you to pause the video, do the work for this, go ahead and graph that line, and then unpause, and I'll do the same work, and let's see if we are arriving at the same solution. Okay, so that you're back, here we go. If you've already done this, I'm going to just be going through this at my own speed. X is equal to 0, so that's 3 times 0 minus 2y equal to 12. 3 times 0 is 0. Adding 0 to 2y doesn't matter, so I'm just going to cancel that out. So we have negative 2y is equal to 12. We'll divide both sides by negative 2. And that gives me y is equal to negative 6. X equal to 1. We have 3 times 1 minus 2y is equal to 12. So that's 3 minus 2y is equal to 12. We'll subtract 3 on both sides. That gives me negative 2y is equal to 9. Divide by negative 2. And that will give us y is equal to a negative 4.5. Now for y equal to 0, we have 3x minus 2 times 0 is equal to 12. Again, 2 times 0 is 0. Adding 0 doesn't do anything. So that's 3x is equal to 12. Divide both sides by 3. And we get that x is equal to 4. And then finally, we need to do y equal to negative 3. So we have 3x minus 2 times negative 3 is equal to 12. Negative 2 times negative 3 is a positive 6. When we subtract 6 on both sides, we're going to get 3x is equal to 6, and then we'll divide both sides by 3, and that will give us x is equal to 2. Okay. Did you get those points? If not, go back and look at your work again. and figure out what went wrong. Okay, so let's plot these points on our coordinate plane. X is 0, y is negative 6. That's going to be on the y-axis at negative 6. 1, negative 4.5. X is 1. Negative 4.5 is halfway between negative 4 and negative 5, right about here. 4, 0. X is 4, y is 0. That's going to be on the x-axis at x equal to 4. 2, negative 3. We're going to go to 2, and we're going to go down 3. So we have those 4 points. They all are lining up in a straight line. We can draw a straight line through those points. By the way, the arrows that we put at the end of the line are there to indicate that this line will continue on indefinitely in these directions. Okay. So definition. X-intercept and y-intercept is the point at which the graph crosses the x-axis or the point where the graph crosses the y-axis. So looking back at our previous example, this point right here is an x-intercept. It's crossing the x-axis, and this point right here is our y-intercept. Now, one way to find or to graph a line is to find the intercepts. So, for finding an x-intercept, to find the x-intercept, we're going to let y equal to 0. And that makes sense because when you come up here to this problem where we had the x-intercept, what was the y value? The x value is 4, and the y value, y, is equal to 0. So to find the x-intercept, if y is equal to 0, that will give you where the graph crosses the x-axis. In order to find the y-intercept, we let x equal to 0. So again, coming back over here to this point, the coordinates of this point, we're at 0, negative 6, where x is equal to 0. So letting x equal to 0 and then solving for y will give you the y-intercept. So this is a method that we can utilize to graph a line. So for each equation, give the x and the y-intercept and then graph the equation. So we have the equation 2x plus 3y equals negative 9. If I want to find the x-intercept, what we're going to do is we are going to let y equal to 0. So we have 2x plus 3 times 0 equals negative 9. And in this form, if y is equal to 0, then that 3 times 0 just goes away, because 3 times 0 is 0, and adding or subtracting 0 doesn't do anything. So we have 2x equals negative 9. Divide both sides by 2. And we get x is equal to negative 4.5. So we have the point in terms of x and y. Remember, your points are always in terms of x and y. We have the point negative 4.5, 0. So this is our x-intercept. Let's go ahead and graph that, negative 4.50. Okay, let's find our y-intercept. To find the y-intercept, we are going to let x equal 0, and then solve. So we have 2 times 0 plus 3y equals -9. Again, 2 times 0 is 0. Adding 0 doesn't do anything. So we have 3y is equal to -9. Divide both sides by 3. And this gives us that y is equal to a -3. So we have the point, again in terms of x, then y. X is 0, y is -3. So when we plot this point, 0, -3 is going to be right here. Now, it only takes 2 points to make a straight line. So you can visualize the straight line going through here. If you wanted to verify that you indeed have the correct solution, you might want to find another point. So what's another point that we could find? So I'm going to be a little bit choosy here. I'm going to let x equal 3. And I'll explain why I let x equal 3 later. So we have 2 times 3 plus 3y equals -9. 2 times 3 is 6. Subtract 6 on both sides. And we have 3y is equal to -15. And the reason I chose x equal 3 is because I knew that by choosing 3, we would get a multiple of 6 right here, which is also a multiple of 3. You combine that with that -9, you get a -15, which is also a multiple of 3, so that when we divide, we get a nice integer, like -5. So the point that we have is 3, -5. And if we plot that point, 3, -5, right there, and that's enough to convince me that I have the correct x and y intercepts. I've plotted a third point. Everything's in line. That's enough to convince me that I indeed have the correct points to graph this equation.